Hello, and thank you for joining us for today's webinar, Unify Endpoint and Network Evidence. With us today, we have Alex Kirk, who is Manager of Global Security Consultants at Corelight, and Ken Green, who is Director of Strategic Alliances at Humio. Please welcome to the virtual stage, Ken Green. Ken, take it away.
Cool, thanks Ed. So I'm going to get you started, get us started today by setting a bit of context with a few slides, and then we'll get to the main event, which is really Alex in terms of showing you all of this stuff kind of in action. So in terms of today's agenda, I'm going to set the scene a little bit with really talking a little bit about the threat landscape, recent changes and challenges there, so we understand what kind of customer problem we're trying to solve here. And really, it is becoming a survival of the fastest. And you're going to hear a lot today about the need for speed, about the need to have fast access to the right data and how that helps you stay ahead. So after that, I'm going to talk a little bit about introducing Falcon, Corelight, and Humio in terms of very high-level product capabilities, how they integrate together, and then I'm going to hand over to Alex, who's going to show it you in action. And then we'll wrap up with a brief summary of how you can actually get started. And you can do everything you see here today for free with that free trial of all the components of today's solution, and then take some questions as well. So the threat landscape, people for a very long time now have been telling everybody, and it's true, that customer environments are getting more complex and getting more dynamic. Right back to my early days, 15, 20 years ago, working in networks, the deperimeterization of the network was what it was all about there, shift to internet and mobile devices, etc. What's really driving this, in my view, now for most large organizations is they are at pace moving to adopting cloud, moving to microservices architectures, and DevOps. And those three things are really accelerating the level of change in terms of their environment, and also some of the complexity in terms of understanding what your environment actually is. Some of those basic SANS, CIS controls around understanding your own environment. The challenge has certainly changed recently. Customers are moving to multiple public clouds. They each have their own proprietary systems and ways of doing things. Microservices means what used to be a nice lump of a single application with a single log file to look at is now many complex, many-to-many relationships between different components. And DevOps, is just the rate of change of new build. Now, all of these things are, in some ways, double-edged swords. It's not all doom and gloom. These things hold huge promise for customers. And in terms of cloud, one of the great things about cloud is these are kind of self-documenting systems. So they generate a log line for every single action and API call within them, which is awesome. So you have access to the right data, but the challenge is the volume of that data sometimes. DevOps, yes, you're releasing things every 15 minutes, not every month now, but that's a great opportunity to also make sure that you're building things in a consistent and automated way, and that if you don't get it right, you've got a very short interval to wait to get it right with the next release. So it's not doom and gloom, but it does mean that these landscapes are getting complex and dynamic and are changing more than ever. Then you throw things like IoT and operational technology in, where the level of access you have to the underlying technologies and embedded systems isn't quite the same. That adds another component to it. At the same time, adversaries are getting better and they're getting faster. More and more attacks. At CrowdStrike, we see most of the majority of the really serious adversary activities and attacks are now not actually using malware. They're living off the land. They're using Active Directory and other regular tools to push out bad configurations and circumvent trust and control points. You've got real hands-on keyboard attacks. So that's obviously using their scarce human expert resource, which means they're turning to AI and machine learning to work out where to spend their time, who looks like the best victim to deploy those resources on. So the race is really around the time and the survival of the the fastest. And we've got this concept of the breakout time. So from when the adversary gains initial access to a system to the point where they're able to move to an adjacent asset, that lateral movement. Now, in that window is really where the window of opportunity exists for the defender to stop an individual incident becoming a major breach. If you can identify, understand, contain, remediate within this window, within this phase, then the level of damage, the extent is not usually that significant and is livable with. However, after this point, things get really bad really fast. So when you get into the things to the right, those red balloons that explode in terms of the level of impact to the customer, it does get exponentially worse the later you are in terms of being able to detect and respond to this. Now, at CrowdStrike, we've been battling the world's most advanced adversaries for over 10 years now. And the CrowdStrike mantra is the 1-10-60 rule. And this is informed by those years of research and working and seeing the attackers get faster. Now, these are very tough targets to achieve, but whether you're using CrowdStrike, Humio, Corelight technology or not, they're really good targets to have in terms of your ability to detect that initial compromise, investigate, get the context, work out the blast radius, and then respond within respectively 1, 10, and 60 minutes means you're stopping things before it starts getting seriously bad. But to do that, you really need to be fast. You need to be fast at having access to the right data. It's all about really the OODA loops, the ability to observe something, orientate that in terms of what it means in your environment, decide and act. And it's being really fast at understanding your own environment. And this is a key thing I want to stress today, because if you can't really understand your own environment, then you're not able to understand whether what's happening in it is really expected, good, bad, potentially malicious or not. Also, understanding the external environment is great, and having a desire to cover MITRE-ATT&CK techniques is brilliant and it's very helpful. But if you don't know how to practically implement that in your own environment, because you haven't got that full understanding, then things are really difficult. So it's about having access to full fidelity data, putting that in the hands of the right people at the right time so they can stay ahead. Now, really, when we talk about full fidelity data, that's just my phrase. The better way to perhaps explain it is evidence-based. It's really not enough to rely now on alerts and detections from multiple different siloed pieces of technology, which are going to tell you a definite known bad thing has happened in your environment, because that doesn't help you understand any context around your environment, and that doesn't help you with threat hunting, that doesn't help you with investigations, that doesn't help you when you're trying to create new detection rules and you want to be able to say, well, what would happen if this rule was in place 6 months ago? Would we have stopped important production systems, or would we have not seen any impact on the good side of our business, but we would have been better prepared? It's really about having access to the full set of evidence. And if you think about how evidence is talked about in the legal profession, they talk about it needs to be compelling, it needs to be comprehensive, it needs to be tamper-proof. And some of those concepts apply here, we believe. So it's about having access to the right data, full evidence level of data, full raw logs. And the value of having access to that, I'm going to talk now about this kind of concept of the left and right of the boom being when you first realize an adversary is in your system. Because the value of the data and how it can be used is different in those two different scenarios. So in the left of the boom, having access to this level of evidence and full raw logs really helps you build the home court advantage, as it's sometimes termed. And this is what should be your single biggest advantage over adversaries. You both have access to some of the same technologies, same people, equally motivated maybe in some regards, maybe equal level of skills, who knows. What your real core advantage should be is that you understand your own environment way better than the attacker. So you're way faster at working out if something is happening, if it's good or bad, and what you should do about it, if it's expected or not. So having access to this data helps you continually refine this home court advantage. Mine that data, compare what you're seeing in your logs to your CMDB to continually have a feedback loop and tune your environment and understanding of it. Once you understand your environment really well and everything in it, you can create those detection rules, not just use an off-the-shelf detection rule that's a generic one, but tune it to your environment. You can work out where to place those rules, where the sort of choke points in your environment are to catch the adversary. And then you'll have really low false positives, of course, as well. Also, having access to all this evidence at the right time, left of boom, it's building forensic readiness for when the inevitable happens in your right of boom. Because, of course, stating the obvious, but those incident response teams can't time travel. They can't go back in time and say, oh, I wish we had access to this information, if only we had been logging this. Because when you're right of boom, it's not the time to start trying to onboard logs into systems and try and collect information you've not previously had. Having it left of boom as well means it's a great platform for threat hunting. We covered this in a previous webinar, so I'm not going to dwell on that, but threat hunting is an awesome capability to have proactive testing of your existing controls and being able to hunt and search for things proactively before you get to the boom. Right of boom, having access to the right evidence allows you to have a much better experience in terms of that rapid initial assessment. The first question is always, are we affected? Are we vulnerable? Have we been hit? And if we think we have, what is the blast radius? How bad is this? They're the initial questions which everybody needs to answer. And if you haven't got data, you don't want to be having guesstimates or being unclear there, because you should probably then assume the worst case scenario, which means then your hunt, your investigation, your remediation, containment actions need to be really broad, which means they're really expensive and time consuming. Having access to the right data in that investigation phase and the response really helps with decision support as well. So often you're faced with making difficult decisions about how to reconfigure things on the fly. And the question that the sort of, business will often ask of the cyber ops is, well, what will that do? Will it break anything? And being able to run simulations of, well, if we introduce this new tighter control now as an interim measure, what will it do to our systems? If you've got access to all the data going back for a reasonable level of retention as well, you can understand that. So you can be confident that what you're going to do is not going to impact your systems in a bad way in terms of stopping things working, stopping revenue and customers being served. And then you've got the investigation speed and confidence. When you want to have a closed investigation, it's really important to be able to give a confidence rating on how confident are you that you've gone back far enough, that you've seen everything the adversary has done. And this is something our own CISO, Simonson, talks about, is this concept of proof of absence is really valuable. And that's, people are very used to searching for things and wanting to find specific bad things, but being able to prove that there was no connectivity to that command and control server, or that never happened in your whole environment, is really useful, because it gives that confidence in the investigation is complete. Therefore, your remediation containment actions can be focused. So why we're talking a lot about endpoint and network data today is because they're great complementary data sets. The endpoint is really deep visibility into those endpoints. It's typically, and certainly the case with Falcon and CrowdStrike, that data is gained by a sensor or agent-based deployment. And because of that, it's got really deep hooks into everything that's happening. It's really pretty much kind of the last line of defense. It's a great place to stop things, but it is quite late in the day sometimes, and potentially there's things earlier, which we'll talk about from the network perspective. And the things you're talking about with endpoints, the indicators of compromise or attack that you're seeing there, you're seeing processors, you're seeing user activity, registry changes, applications, you're seeing file hashes, you're seeing operating system changes. That's what you're getting at the endpoint. At the network layer, it's very different. This is why it's good and it's complementary. The network is standards based and you've got broad coverage. So it might not be massively deep, but it's really broad. And that's why they go really well together. If something's not using the network, then it's probably not going to cause you a huge amount of pain or damage. Everything has to use the network at some point, is the other way of looking at it. So you're talking about passive sensor-based things, which means it can support also a really wide variety of network traffic without having to understand all the differences between those things and without having to be locked into a particular vendor's approach. and you're detecting things in the early stages of attack potentially, and you're creating observable things such as IP addresses and domains and connectivities and URLs. And if you bring both of those things together, that complementary nature really means you get awesome observability and visibility into what's happening because of those two different types of log sources. And also being able to share observable artifacts such as IOCs between those gives you a lot of value. If you can take an IOC of a file hash which is seen executing malware on the endpoint, if you can look for other devices which maybe don't have endpoint protection, maybe they're IoT devices that can't have that, or it's a partner's device that you don't actually own or control, but maybe they're talking to the same bad kind of control things, there's a great way to kind of spread that intelligence and get the higher levels of protection by using observable artifacts in one solution in the other. Excuse me. Now, in terms of talking about how these solutions work together, I'm going to very briefly show you a high-level kind of diagram here of how these things are working and what they are. So we're talking today with Corelight. Corelight are a network company, of course, the main thing to note. What they essentially do is they're creating network metadata from a broad array of passive monitoring of network traffic. In the physical world, then we have Corelight physical sensors, off-tap and span ports. In the cloud and the virtual world, it's using traffic mirroring and other techniques to ensure no matter where the network is, and whether it's real, physical, virtual, logical, cloud, whatever it is, Corelight have a solution for it. And one of the really cool things about Corelight is because of the breadth of coverage, it really often replaces having to onboard multiple different network solutions and log sources into your analytics tool. So Corelight are covering DNS, HTTP, SSH, they're covering files, they're covering SMB, they're covering a really broad set of things, all in one kind of solution and consistently. So it can be a really efficient way of getting the broadest coverage across all of your network. And Corelight is generating a lot of data, but it's only generating about 1% of what packet capture would be. Packet capture isn't feasible over more than a few days or weeks for most customers because of the volume. At the other end of the spectrum, you've got people relying on network-based detections from firewalls, load balancers, and proxies and web gateways. But again, that's not enough data because it's only telling you about the known bad. Corelight sits really nice in the sort of Goldilocks zone of the right level of data. Yes, it's a lot of data, but it's that full evidence you need without having to be packet capture level of volumes. And that can be sent both from the raw logs, all of the Corelight data, as well as alerts from things like the Suricata integration into Humio for analysis and detections. Falcon is CrowdStrike's and the industry's leading endpoint solution, of course, and Falcon is obviously capable of generating detections for customers to tell you what it stopped and why. What we're interested in here, though, is again that full evidence base. So the Falcon agent is able, well, actually the Falcon agent reports to the cloud, of course, and the cloud is able to give customers a feed of all of the raw telemetry that's coming off that endpoint, not just the detections. And bringing that into Humio allows you in Humio to have that visibility into everything that's happening at the endpoint and everything that's happening at the network. So your SOC can create detection rules, your threat hunters can hunt in that, and you can have detections trigger into SOAR platforms, etc. And then between the two solutions, between Corelight and Falcon, we have got, without Humio even being in the place, we've got already threat intelligence exchange. So you can, make use of observations in one and the other. And then with Humio, you can actually look at the raw data and correlate that together. And that's what Alex is going to show you in the next session of today's webinar. And thanks for letting me set that context. Nice to join you. I'm going to hand over to Alex now for the actual demonstration. Thanks, Alex.
All right, thank you, Ken. So what we're starting out by looking at here is a notice coming off of the Corelight device for the CVE 2021-44228. For those who might not have had it drilled into their brains, this last December is Log4j. This is for the detection of the actual second stage Java payload being downloaded, as opposed to just the exploit attempt going forward in the first place, since this is much more indicative of an actual compromise than the potentially thousands of hits you might get on exploit attempts, given how many folks are spraying those all across the internet. And what we can see is that we've got a lot of information in the notice about who are the systems involved, what ports were it on, all those sorts of standard things you get out of an alert. But the critical piece of this puzzle from a Corelight perspective is this UID field. That is a unique identifier that we lay down on a per connection basis across all of the logs, so that it's very easy to do a pivot when you get an alert like this into the metadata that Ken was talking about a moment ago, all of that sort of non-judgmental logging of everything that happens on the network, period, so that when you do get these alerts, you can go back in and start to dig into exactly what is going on around there. And in particular, in this instance, for example, we can see in the HTTP logs that we have a URI that's being fetched of exploit.class. Probably a much sneakier name would be observed in the wild, of course, but for demo purposes, it's always fun to put names like that in. We can also see that we've pulled that file off of the wire, and it's available in any kind of sandboxing or other sort of setup that you might want to do file analysis in. We see that there was additionally a couple of suricata alerts on that same connection, all about a vulnerable Java version being detected, downloading an exploit class file. So, pretty clear confirmation of, an exploit taking place, and it's something that we're going to want to dig into. So the first thing that I would do as an investigator is dig in a little bit to the connections between the two hosts that were involved in this compromise and see kind of what else they've been doing with each other on the network. And one of the things that you'll notice pretty quickly here is, okay, 8080 is probably the port that the log4j attack came in on in the first place. There's some SSH traffic, which is definitely not a good sign. But even weirder, there's this port 9001 that I'd want to dig into to understand exactly what was happening there. And the cool thing in this particular case is we've got this spcap.url value in the log here. What that is while Corelight is not collecting full packet capture by any means, because as Ken alluded to, it's difficult to get days, let alone weeks worth of look back on something like that. We have a smart packet capture feature that is driven by predefined policies you can set. And in this particular one, the policy here is unknown TCP, which is essentially saying we saw a TCP connection that contained some sort of traffic that the underlying metadata engine did not understand. And so it's easy to grab this URL and pivot over to that collected PCAP, which if we were to go ahead and follow the stream on here, we can see is actually a reverse shell taking place in between these boxes. And because we've got the capture of that shell, we can see exactly what commands were being executed by the attacker once they were able to get that shell established through the log4j exploit. And one of the things we noticed that they did in here is said, all right, what kind of connectivity do I have inside of the environment? And while there's the 10.0044 address that we saw as part of the log4j notice that's its external connection here, we can also see that it's got an address on an internal subnet that is designed to be protected from the internet and has some of our kind of crown jewels on it. And so at that point, we definitely need to dig a lot further in and see what this box has been doing on that segment of the network. And so pivoting back into the logs here, what we're going to want to do is say, all right, give me all of the connections that this host has been making, and group it by the systems that it's connecting to on the ports, and get an idea of what exactly is going on. And we can very quickly again see that there's a whole lot of connections on odd ports here. 4455 looks a lot like 445, which is the standard SMB port, but is also something that is often used by attackers to be easily missed in a long list, since it looks like something legitimate but is not. And so at that point, I said, let's go ahead and see if we have any alerts for those particular systems. We dive in to that with the notice log, and we can see that there are actually interpreter connections being detected as well between those two systems. And so there's definitely been lateral movement within the environment. So at that point, I would really want to dig in to what has happened on this box that has been connected to with another shell in the environment. And so at that point, I'd really want to pivot over to the Falcon logs and start to investigate a little bit deeper in terms of what happened on that session. And the way that we can kind of glue together the network and the endpoint is by this local address IP4 value, which is something that is going to show up in all of the logs where a particular host is talking to the network. And in this particular case, we're coming up with no results, which, okay, maybe it's, a third-party device, or there's been some other failure in getting the agent onto the box from, an organizational or policy level. What we can do here, though, to talk through the story a little further, is one of the other hosts that was present inside of that earlier set of connections from our compromised system is this .60 address as well. And what we need to do to really get into the bulk of the Falcon logs is come down here. There's this value AID, which is the agent ID. And that's kind of like that UID from the Corelight logs earlier, in that it glues together everything that is present in the Falcon logs for that particular agent, whether or not it's something that's talking to the network. And so we can go ahead and do a pivot on that agent ID. And at that point, we've got 93,000 hits across a whole variety of different event types. And if we're trying to figure out, all right, what is relevant in here, what's the place I want to start as I dig in, well, maybe we want to go ahead and see if there were any detections coming off of Falcon as well. And at that point, we can just do a group by tactic here inside of Humio, because that field pops up if there's ever an alert, what was the tactic that was used to detect it. And we see that we've got hits on machine learning coming off of Falcon. And if we dive into those to try to get a better idea of what's going on, we can very quickly see, oh, look, there's a command line of payload.exe. Again, a little bit of fun with the names from a demo perspective. But we can see that it's coming off of the network. And at that point, maybe we want to dive into what else is going on with this SMB share, and validate exactly how things are moving in the environment. And since we have, by virtue of having been on the box, the MD5 of that malicious payload, then we can go ahead and grab that, pivot back into the Corelight logs with that MD5, and we see, okay, yes, this was definitely sent across the network between those hosts in question. We're going to go ahead and grab out of the file log here the UID of the connection on which it was observed, and do one more quick pivot. And we can see, if we look in here, yes, this was SMB files going on. We can see that it was indeed, server one share payload.exe, confirming exactly what we saw on the endpoint. But then branching out a little bit, we might say, well, what else have these two hosts been doing from an SMB file perspective? And so with a quick search through the data here, we can look at this and see, the names of the files that we're moving, one of which right on top here is gpt.ini, which for those that might not be familiar with it right away is a group policy coming off of an Active Directory server. Of course, our CMDB can confirm that, hey, this .60 address is indeed one of the Active Directory boxes in the environment. And digging in from a forensics perspective on that host, we're able to see inside of the group policy management, running these programs at user logon, there's our server one share payload.exe, just as expected. And really at that point, we want to dive through the group policy and see what other changes have been made recently, see what other sort of time bombs might be lurking in there for us from a forensics perspective. And really that's the beauty again of tying these two systems together is coming over here and looking at some additional interpreter notices that we saw within the environment, pulling that IP address, getting the Falcon information about what it is. And then diving in to these endpoint logs. So I can actually click on the right thing here. Again, we can see a whole ton of useful forensics information being collected, and in this case, because I, have set this up and know what's going on here, what if we say, based on interpreter, we often see PowerShell with it as well, since it's a common technique being used by adversaries in the wild. Well, yes, it's actually popping right up here in those endpoint logs. We've got the level of detail of the exact PowerShell commands being executed, all of that forensic artifacts and information that's necessary to have that understanding of the blast radius, as Ken put it, and being able to make decisions quickly about what you need to do to remediate and exactly how you're going to respond to these incidents in that timely manner that allows you to contain things before they become too problematic. So that is the end of my demo. I'm going to go ahead and pass back over to Ken at this point.
Cool, thanks, Alex. Great, thank you very much. That was awesome. And I think, as I mentioned earlier, we are going to tell you how to get started for free and effectively do everything that Alex did for free. Ed, do you want to have a start by talking through the Corelight at Home program? I know it's something you're very involved with and very passionate about.
Yeah, sure, happy to. Thanks, Ken. Yeah, so as far as Corelight at Home, looking at the green box in the middle of the screen here, Corelight at Home is a program to use Corelight software on a Raspberry Pi. We have a free license that you can use, and it's a great way to understand what's happening with devices on your home network. There's actually a couple SANS webinars that we've done. You can look those up on our YouTube channel, where people have shared some of the interesting, cool, and sometimes strange things that they found on their home network. Things like employers using software to monitor employees at home, having your Tesla Model S car phone back to the mothership. So a lot of kind of fun and interesting things that you can find on your network. A great way to get your hands on Corelight evidence and gain insight in your home network. Also very good complement for Humio Community Edition, where you can send logs from your Corelight sensor into the free Humio Community Edition as well. And then Ken, you want to talk about that as well as the Falcon trial?
Yeah, sure. Yeah, thanks, Ed. Yeah, and I love the stories you guys get around what people's fridges have been talking to at night and stuff. And I've seen some interesting things from my Wi-Fi controlled electric radiators in my home office as well, which definitely isn't in the instruction manual or the feature list that comes with it. Humio Community Edition, it's our way of giving people completely for free access to experience Humio. So you can sign up for this on the link here via our website. No credit card required. It's not something that expires, and we're not put you in a pressure sales situation. We want people to get their hands on Humio, and the only limitations to it really are that there is a 16 gigabyte per day ingest limit, but that's a pretty sizable volume for even some small business use cases as well as home stuff. And there's a 7-day retention period on it. But it allows you to experience the full value of it, and it's a great complement for Corelight at home. And inside Humio, we have some Corelight packages which contain pre-built dashboards and searches that really help you visualize the data from your Corelight sensor, whether it's from your home sensor or an enterprise one. The packages and the dashboards work in exactly the same way, so it gets used to interacting with the data. And then from the CrowdStrike Falcon perspective, on the link on the Go CrowdStrike website, you can sign up there for a free 15-day trial for Falcon as well. So, if what we've shown you today looks interesting and you want to experiment with it, we've hopefully made it really easy for people to get started and to experience for themselves some of the possibilities here with their own logs, as well as a interesting thing actually, which I'll cover on the next slide, which is a very recent thing just last week, where inside Humio Community Edition, we now have a sort of sample set of logs from a Corelight network sensor. These logs are on a kind of continual replay loop, so they're constantly new logs arriving. And when you sign up for Humio Community Edition, on the right-hand side, there'll be a link to a blog article, which really, it's a nice tutorial which talks you through, assuming zero knowledge of Corelight, Humio, or any query language or any real technical capabilities. It's really aimed at the novice beginner user and talking them through step by step about how to do some interesting searches, look at some dashboards, pivot to find out who is downloading those Shockwave flash files, where they're coming from, create an alert for it. So that's something which we're really excited to bring into Humio, because Corelight's an interesting data set. It's really broad. And as you see, if you work through the tutorial, there's a lot of interesting things you'll find in there. So that's a great thing to get started with. Now, just before we kind of wrap up and head into Q&A, which is going to be moderated by Ed, I'd like to really thank everybody for joining today. It's been very, very interesting from our perspective to get opportunity to work with Corelight and to explain the value of the two really interesting different data sets. Again, it's coming back to that, the endpoint-based Falcon giving you a really deep set of data, but that being complemented by the network data from Corelight, which is really broad, and how bringing those two things together gives you the best threat detection coverage, the best source of data to threat hunting, and how, hopefully we've shown with Alex's demonstration, the ability to pivot between those data sets using those correlating agent IDs and IP addresses and other fields to really very, very quickly observe how the endpoint and the network are interacting, taking those artifacts from one and looking for them in the other, and how that is going to help you with that moving towards the CrowdStrike mantra of that 1-10-60 in terms of being able to be faster than the adversaries, and having that really fast way to understand your environment and what's happening in it will keep you ahead of those adversaries and stop that incident from becoming that major breach. Thanks very much for joining us today, and I'll hand over to Ed for some Q&A if we've got some. Thank you.
Great. Thank you, Ken. We'll go ahead and open up the Q&A session. If you have questions for our presenters, please enter them into the questions window in the GoToWebinar interface. First question, will a recording of this event be available afterwards? Yes, we will be sending out a link to this recording to everyone who attended today. Next question. I know that endpoint and network logs can generate a ton of data. Are there limits in Humio to the amount of data ingested?
So I'll take a stab at that if that's okay, Alex. So sorry, Ed, there's network data, there's a ton of volume or a ton of logs. So yes, let's not beat about the bush here. Corelight can generate an awful lot of data, which is really good because that's exactly what you need. Now, Corelight has options in Corelight around how you can filter out certain types of events. If you're concerned about overwhelming your log management solution, that's something you could look at doing. With Humio, one of the reasons why we're really very closely partnered with Corelight and we do a lot of work together is because they certainly generate a lot of data, and Humio is the best platform on the market for ingesting very large volumes of data very quickly. Humio's architecture is the fastest out there in terms of ingesting and being able to search data. We've got a unique index-free architecture, which really means that is very infrastructure light, and that effectively translates to cost-effective and fast for our customers, whether we're running it as a cloud service and it's us having to obviously build and buy infrastructure, or whether it's a customer running self-hosted Humio. We typically quote that for a certain level of data volume ingest and expecting a sub-second search speed, that Humio will only need about 20% of the infrastructure of other log management solutions that are out there in the marketplace. So yes, it's definitely a very high volume data set, as is Endpoint with Falcon, of course, but that's why Humio is the perfect tool to do this in, because it's purpose built to absorb these humongous, very, very large sets of data and being able to search across that very quickly. And just to kind of add as well from the Falcon perspective, we have a direct integration of being able to bring that data into the Humio interface without the customer having to do anything. You basically put two configuration items in terms of to link Humio with Falcon, and all of that FDR data will then appear in Humio. So it's also very easy to set up these integrations with the packages in the marketplace as well. So yeah, hopefully that's kind of answered that one, Ed.
Great, thank you, Ken. Next question. What about other log sources besides endpoint and network?
Yes, it's a classic question, but one that's definitely relevant today. You know, and I think, Ken, we definitely agree that like identity management sorts of logs, trying to understand that user as they move between devices and different portions of the network is probably one of the most relevant additional logs that you can bring in. But you know, to your point about Humio's ability to absorb large volumes of data, you know, I think that as long as those additional log sources have a clear use case, and they're not just more data for the sake of more data, then definitely having those brought in and correlated and you know modeled together is going to make you able to respond faster to things with more context, with more confidence. So certainly, yes, more logs are good as long as they're there for a good reason and not just because somebody thought we ought to be logging.
Yeah, absolutely. And if I can just add to that, Alex, yeah, certainly, as you know, Humio's tagline is log everything to answer anything. And we do have customers which literally do that. The reason why we focus today on endpoint and network is they're the two highest value log sources. So they're the first two to address. Adding other ones, identity, email gateways, asset and data orientated data sources, yes, very useful, and it all helps build a better understanding of your environment. It helps build that home court advantage of being able to query your environment and look at the logs to validate what you think your environment is and what CMDB is telling you should be there. It's very, very helpful, but we focus today on the two highest, most valuable log sources in our view.
All right, looks like we've reached the end of our questions. So I'd like to thank Ken and Alex for joining us and sharing their expertise today. And I'd like to thank everyone for attending as well. We'll go ahead and wrap it up. Thanks again. Have a great day.
Thanks all.